mean and variance of continuous distribution, continuous probability distribution. Till now we discussed about discrete probability distribution. Now we are going to discuss continuous distribution. When the density function is defined instead of distribution like this. Already we discussed this concept. Density function. Again once recall, because without density function we cannot define mean and variance. So density function you all know, which is represented by small f of x, which is derivative of distribution function, which has an important property integral minus infinity to infinity f of x dx is 1. So this we discussed already, but to discuss mean and variance we have to describe about density function. What is density function? So density function is this one. When density function is given in a particular interval, then we are going to find mean and variance for that continuous distribution. So now the mean of the distribution is, which is represented like expectation of x, or mu, symbol of mean is mu, which is called average value, integral minus infinity to infinity x into f of x dx. So this is a formula for mean in continuous distribution when x lies between minus infinity to infinity. If x is defined on a to b, that means a less than or equal to x less than or equal to b, then the same formula will be like this. Expectation of x is integral a to b x f of x dx. What I mean to say here is, if small f of x is defined between 1 to 3, then expectation of x is integral 1 to 3 x f of x dx. If f of x is not defined in a particular interval, then we take the total interval like this. If x greater than 0 is the interval, x greater than 0 means starting from 0 to we don't know. There we will take the limit infinity, 0 to infinity. X less than 0. So less than 0 values means from where we need to start, minus infinity. So this is the total interval. Okay, so this is mean formula. We all know the variance represented by sigma square. Its formula is expectation of x square minus expectation of x whole square. Expectation of x is mean. So how to calculate expectation of x square? Where expectation of x square in total interval integral minus infinity to infinity x square f of x dx. So coming to the median also, we will discuss median mode also. What is median? Median is a value which divides the total distribution into two equal parts. Median is a value which divides the total value into two equal parts means in total interval density value is 1. Here let median is m, then what happens? Median m when if a less than x less than b is the interval, then we define like this: integral a to m f of x dx equal to integral m to b f of x dx equal to 1 by 2. Median is value of x. Median is a point which divides the entire distribution into two equal parts like this. Median is value which divides the entire distribution into two equal parts, two halves like this. Here m is median. I defined that value in AB interval. If you take minus infinity to infinity, here you will have minus infinity to m to infinity. Clear? Like that one can evaluate median value. So coming to mode is nothing but a maximum value. Simply what we can say, the value of x for which f of x is maximum. The value of x for which f of x is maximum, that value of x is called mode of the distribution. So this mode of the distribution can be calculated using maximum minimum principle for single variable, which we learned in intermediate level itself. Maximum minimum of single variable, especially for maximum case, what we will do, we equate for f dash of x 0 if f double dash of x is less than 0, then x is maximum value in that interval. For f dash of x 0, find x value. If you substitute that x value in f double dash of x, if you get less than 0, then we call x is maximum. That will be the mode for the distribution. Are you clear? Here we are going to use these formulas repeatedly. Mean formula and variance formula. Variance. And also here itself, for calculating probabilities between any two values, whenever density function is given, you need to integrate the density function within the given limits. That also we are going to use repeatedly for calculating some probabilities between any two values in continuous distribution. We use integration. So if you observe the discrete and continuous distribution, you can clearly get idea about the mean and variance in discrete and continuous. What is the exact difference? In the case of discrete, we are taking sigma x p of x, probability distribution function. Here you will have sigma, here you will get infinity. There is finite case, discrete, 1 to n, this is infinite case. There you will have sigma x p of x, in the place of sigma you will get infinity here. There, to calculate probabilities between any two values, you are going to add, you are going to integrate here. That is the difference. Are you clear? What is mean and variance for continuous distribution? Any doubts you may express? F of x with the distribution function of a random variable given by capital F of x equal to cx cube. When 0 less than or equal to x less than 3, 1 when x greater than or equal to 3, 0 when x less than 0. So first we need to find the density function. Next, corresponding density function, we need to find C and mean variance, mean and probability of x greater than 1. So for that, first to find density function. We all know that density function we represent like a small letter f of x, lowercase, is the derivative of distribution function. So d by dx of, so the non-zero cases we need to do first, cx cube, then what happens? Differentiation of x cube, d by dx of x cube is 3x square. So differentiation of x power n formula, n into x power n minus 1. Using that, you will get 3cx square. Now, if you define the exact density function in that interval, so the density function small f of x is 3cx square in 0 less than or equal to x less than 3, 0 otherwise, excuse me, 0 otherwise. Why? Here, if you differentiate 1, differentiation of constant 0, differentiation of 1 0, already this one is 0. So only in this interval you will have 3cx square. In remaining interval, automatically the density function becomes 0. Now, to find C value, to find C, By using the important property of density function, using density function property, we know that integral minus infinity to infinity f of x dx is 1. This we know. We know that integral interval is, here our interval is 0 to 3. So integral 0 to 3 small f of x 3c x square dx equal to 1. So now 3c constant, integral x square, this formula integral x power n plus 1 by n plus 1. If you use this formula, integral x square x cube by 3 limits from 0 to 3. Here 3 get cancelled. If you write in the place of x3, 3 cube, 3 3s are 9, 9 3s are 27. So 27c is 1. So c value will get 1 by 27. So coming to the third case. Third bit. Find mean. What is formula for mean? Mean we represent like mu or expectation of x. What is formula for mean in continuous distribution? We discussed already. Integral infinity to infinity, but our interval is 0 to 3. X f of x dx. X f of x dx. Integral 0 to 3. What is small f of x? Small f of x is 3c x square x into 3c x square dx. But we know that c value is 1 by 27. If you write in the place of c 1 by 27, 3 into 1 by 27, integral 0 to 3, x into x square, x cube dx. 3 1 ja, 3 9 ja, 1 by 9, integral x cube, x power 4 by 4, 0 to 3. So finally here, 1 by 9, right in the place of x3, 3 power 4, 3 cube 27, 81 by 4. So 9 1 ja, 9 9 ja. 9 by 4 you will get mean. Okay, this is 9. Coming to the last bit. Probability of x greater than 1. X greater than 1 means greater than 1 starting from 1 to final value. Final value, what is final value? 3. 1 2 3. If you don't have that 3, we will take infinity. Integral 1 to 3 f of x dx. What is f of x? F of x is 3c x square. What is c? We know c value 1 by 27. Right in the place of c 1 by 27. 3 into 1 by 27 x square dx. Integral x square. 3 1 ja, 3 9 ja. Integral x square x cube by 3 from 1 to 3. So you need to substitute upper limit and lower limit. 1 by 9 into, right in the place of x, 3 first. 3 cube, 27 by 3. Right in the place of x, 1 by 3. So there you can cancel. 3 9 ja, 9 minus 1 by 3. You can simplify. You will get 26 by 27. Probability of x greater than 1. Okay, any doubts anywhere you may express. If a random variable has the probability density, so density function is given 2e power minus 2x for x greater than 0 and 0 for x less than or equal to 0. Find the probability that it will take on values between 1 and 3 greater than 0.5. These two we need to find. So first write what is given. So given the probability function for non-zero case, I am writing 2e power minus 2x for x greater than 0. Now we need to find probability between 1 and 3. That is this one. P of 1 less than x less than 3. So, which can be evaluated like this? Integral 1 to 3, between 1 and 3, right? Integral 1 to 3, f of x dx. Integral 1 to 3, what is f of x? 2 e power minus 2x dx. 2 constant. Integral e power ax. Integral e power ax is e power ax by a. So using that, integral e power minus 2x by minus 2. Limits from 1 to 3. 2 get cancelled. If you keep this minus here, write in the place of x3, e power, if you write here 3, e power 2 3s are 6 minus, write in the place of x1, e power minus 2. Use your calculator to get this e power minus 6, e power minus 2 values. What you will get? 0.1328. Use your calculator to get that value. Next, coming to the second bit. What second bit says? Greater than 0.5. That means P of x greater than 0.5 value we need to calculate. P of x greater than 0.5. X greater than 0.5. That is from 0.5 to, the upper limit is not given in the question also. Greater than 0. Starting from 0 to, we don't know. There we take infinity. F of x dx. What is f of x? Integral 0.5 to infinity 2 e power minus 2x dx. 2 constant. Integral e power minus 2x dx. Integral e power ax. We know what is integral e power ax? E power ax by a. So like that, e power minus 2x by minus 2, limits from 0.5 to infinity. So 2 get cancelled, keep this minus 2 outside. Here e power, if you write in the place of x infinity, minus 0.5 means 1 by 2. I am writing here 0.5 as minus 1 by 2. Then we will cancel 2. We all know that e power minus infinity is 0. So that means this becomes 0. Minus into minus plus, e power minus 1 you will get. Use your calculator to get e power minus 1 value, 0.3678. If you use your calculator, you will get that answer. Like this, whenever a density function is given, we can calculate the probabilities easily. A continuous random variable x has distribution function, capital F of x is given. Find the probability density function and k value. So to find density function, we know that the density function small f of x equal to d by dx of capital F of x. What is non-zero case of capital F of x I am taking? If you differentiate 0, you will get 0. If you differentiate 1, differentiation of constant 0. So I am taking this one, k into d by dx of x minus 1 whole power 4. By using famous differentiation formula, differentiation of x power n into x power n minus 1. So we can evaluate that one. 4k into x minus 1 whole cube. 4 minus 1. 4 into x minus 1 whole power 4 minus 1. Differentiation of x is 1. So this we will take it as small f of x in the interval 1 less than or equal to 1 less than x less than or equal to 3. In this interval we are calculating. In remaining all intervals, what happens? 0. 0 otherwise. Now density function is over. Next we need to calculate k. To find k, the important property of density function, we know that integral minus infinity to infinity f of x dx is 1. We know that. Using this, in given interval, integral 1 to 3 4k into x minus 1 whole cube dx equal to 1. So 4k is constant. 4k into, using this formula, integral x power n is x power n plus 1 by n plus 1. Integral x minus 1 whole cube is x minus 1 whole to the power of 4 by 4. X minus 1 whole to the power of 4 by 4. 4 cancel. Limits 1 2 3. 1 2 3 limits. Now k into, write in the place of x 3 first. If you write in the place of x 3, what you will get? 2. 3 minus 1, 2 power 4. Minus, write in the place of x 1, 1 minus 1, 0. So 2 power 4 we know, 16. 16k equal to 1. So finally k equal to 1 by 16. In continuous distribution, this is the very most important formula to calculate any constant value for given density function. Are you clear? Any doubts anywhere you may express. For continuous distribution f of x equal to kx square e power minus x for x greater than 0. Then find k. K value we need to find. So given density function is small f of x equal to kx square e power minus x for x greater than 0. Density function is given. We know from property of density function, we know that integral minus infinity to infinity f of x dx is 1. But our interval is x greater than 0. Starting from 0 to not given, then we will take infinity. So whenever any limit is not given, that limit we will take the standard limits minus infinity to infinity. 0 is given, this limit I am taking infinity. F of x dx equal to 1 as per our given problem. What is f of x? F of x is kx square e power minus x dx. K constant. Here we are going to use uv formula. So integral uv u integral v dx minus integral d by dx of u integral v dx whole dx. So you can use a Bernoulli formula also, uv1 minus u dash v2 plus u double dash v3. So this one is standard integral uv integration by parts formula. Using this, keeping k constant, I am writing limits at the end. I am not writing limits now. So forget about limits. Limits are 0 to infinity. We will keep at the end. So u is x square, v is e power minus x, integral e power minus x dx minus integral d by dx of u is x square, integral e power minus x dx whole dx equal to 1. Now we all know that integral e power minus x is minus e power minus x. Actually e power minus x by minus x, we can take that one as minus e power minus x, and differentiation of x square also we know. Differentiation of x square is 2x and differentiation of x is 1. If you use that formulas, what you will get here? X square e power minus x is minus e power minus x. Here integral x square is 2x, e power minus x is minus e power minus x dx. Limits 0 to infinity. So coming to here, again you got x e power minus x by taking x as u, e power minus x as v, again using this formula. What you will get? K minus x square e power minus x, minus into minus plus, that 2 I am writing here. I am treating x as u, e power minus x as v. Again I am applying this one. So if you apply that formula again, x integral e power minus x dx minus integral d by dx of x integral e power minus x dx whole dx equal to 1. So now simplify very carefully. K into minus x square e power minus x, this one is same, plus 2 into integral e power minus x minus e power minus x, you will get here minus x e power minus x minus d by dx of x is 1. d by dx of x is 1. If you integrate e power minus x 2 times, if you integrate 1 time you will get minus. If you integrate again e power minus x, you will get one more minus. Minus into minus plus. What I am saying, if you integrate e power minus x 2 times, you will get e power minus x only. Minus into minus plus. So e power minus x only you will get equal to 1. Limits 0 to infinity. At the end we are substituting limits. Any doubts you may express anywhere. Simply we applied this UV rule 2 times. Nothing is there. Now write in the place of x infinity first. Next write in the place of x 0. While writing in the place of x infinity, you all recall this one, e power minus infinity 0, e power 0 1. So if you write in the place of x e power, in the place of x infinity, e power minus infinity 0, this term becomes 0, this term becomes 0, this term becomes 0. So complete total terms become 0 for infinity case. Coming to 0 case, I am writing here. If you write 0 here, this becomes 0, plus 2 into, this becomes 0, this is 1, e power minus infinity, e power minus infinity also, e power 0, right, if you write in the place of x 0, this becomes 0, if you write in the place of x 0, this becomes 0, if you write in the place of x 0, e power 0 1, so here only you will get 1, remaining all 0. This x infinity case, 0 case. Infinity case total term becomes 0. For 0 case this becomes 0, this becomes 0, this is only 1. Now what you are having? Minus into minus. Minus 2 you are having, minus into minus plus. So 2k equal to 1. Now what is k? K equal to 1 by 2. This is we need to evaluate. K value. Clear? Any doubts you may express anywhere. K value is 1 by 2. The probability density function f of x is kx square in the interval 1 to 3 is given. 0 elsewhere. Then find value of k and find the probability between 1 and 3 by 2. These two we need to find. We all know from the fundamental principle of density function, integral minus infinity to infinity, we know that integral minus infinity to infinity f of x dx is 1. So that is fundamental principle of density function. Here the density function for non-zero case given is integral minus infinity to infinity kx square dx, but our limits are very clear. 1 to 3 is given. 1 to 3. 1 to 3. So k constant, integral x square, using integral x power n plus 1 by n plus 1, integral x square is x cube by 3, 1 to 3 dx equal to 1. Now, k by 3 constant, you can keep like that, right in the place of x3, 3 cube minus 1 cube. We all know that 3 cube is 27 minus 1. 3 cube is 27, 27 minus 1, 26. So, k by 3 into 26 is 1, k equal to 3 by 26, k value. In the given interval, kx square dx, k constant, integral x square x cube by 3. If you write in the place of x3, 3 cube minus 1 cube, 3 cube is 27, 1 cube is 1, 27 minus 1. Okay, 3 by 26 is k value. Coming to the next one, probabilities between 1 and 3 by 2. So to find probability between 1 and 3 by 2 whenever a density function is given, what we will do? We will integrate the function between 1 and 3 by 2. That means like this. 1 to 3 by 2, small f of x dx. What is f of x? Kx square. Integral 1 to 3 by 2, kx square dx. But we know the k value is, k value 3 by 26. So write in the place of k 3 by 26 and integrate x square. Integral x square, we all know that x cube by 3 from 1 to 3 by 2. So here 3 we can get cancelled. 1 by 26 into, right in the place of x 3 by 2. 3 by 2 whole cube minus 1 whole cube. 1 by 26 into 3 cube, 27, 2 cube, 8 minus 1. So if we take 8 LCM, what happens? 1 by 26 into 8 LCM, 27 minus 8. Subtract 8 from 27, what you will get? 19. So this will be the answer. For probability between 1 to 3 by 2. You can keep fraction like that, or if you want you can calculate using your calci also. Okay, any doubts you may express. Finding probabilities in continuous means between two values integrating density function. Nothing there. For a density function k into 1 minus x square, in the given interval we need to find k and mean. So to find k, we all know that first given function I am writing for non-zero case only. Given density in non-zero case, k into 1 minus x square for 1 less than or equal to x less than or equal to 3. For this we need to find k. We know that integral 1 to 3 f of x dx is one of the most important property of density function. Density function property. Using this, integral k into 1 minus x square dx equal to 1. K constant. Now integrate. We all know that integral 1 dx is x and integral x power n dx is x power n plus 1 by n plus 1. Using these two formulas, what we can write here? Integral 1 dx x, integral x square, x cube by 3, 1 to 3. Now write in the place of x3 first, next 1. If you write in the place of x3, what you will get? K into 3 minus, for x equal to 3. If you write in the place of x3, 3 minus 3 cube by 3. Minus, write in the place of x1, 1 minus 1 by 3 equal to 1. So k into 3 cube by 3, 3 square. 3 minus 9, 3 square is 9, right? 3 minus 9 minus 3. So coming to here, 1 minus 1 by 3. If you take 3 LCM, 3 minus 1, 2. 2 by 3 equal to 1. Now take 3 LCM again. K by 3 into 3 these are 9. 2 minus 9 minus 2 minus 11 equal to 1. So what you will get? K value 3 by 11 minus 3, but probability never be a negative value, so take this one as positive. Okay, here maybe this is not a probability, okay, you may take minus, negative, no problem. This is not probability, right? In the case of discrete case, K will be the probability, that's why we will take positive value only. Here K minus 3 by 11. Now we are going to find mean. You can take positive also, no problem, plus 3 by 11. So mean, because in the case of mean and averages are always positive. If you take negative also, then you need to make positive. That's why. So K integral 1 to 3 x f of x dx. Integral 1 to 3 x into f of x is 1 minus x square into k. What is k? 3 by 11. 3 by 11 integral 1 to 3. If you multiply with x minus x cube dx. Integral x square by 2. Integral x cube x power 4 by 4. 1 to 3. 3 by 11 into, if you keep minus, that will become plus. If you keep plus at the end also, if you get negative, make it positive. So write in the place of x3, 3 square by 2 minus 3 power 4 by 4. Next write in the place of x1, 1 by 2 minus 1 by 4. So finally 3 by 11 into 3 square by 2, 9 by 2 minus 3 power 4, 81 by 4 minus, if you take 4 LCM, 2 minus 1, 1 by 4 you will get. So finally, if you take 4 LCM for all, 2 9s are 18, minus 81, minus 1. So 82, subtract 18 from 82, 82 minus 10, 72. If you subtract 8, what you will get? 66. So 3 by 11 into 66 by 4. So if you calculate, you will get the answer. So if you keep minus, what happens? Total minus, here also minus 66. Finally you will get positive value. Any doubts you may ask anywhere.